Hello guys. In this next video, we're once again going to be going over interest and making money by investing money or taking out a loan and knowing how much you're going to owe. So if you guys watched the last video, this should look pretty much identical because it's the exact same problem we did in the last video. The one difference, there's one difference. It's this word right here. That's all I did, is I added the word continuously. And you guys can see how much of a difference that's gonna make. So Drew deposits $3,000 into a savings account where he earns interest at an interest rate of 5% compounded continuously. How long will it take for Drew to have a total of $4,000? So in the last video, we were just talking about like just regular compound interest that the cycle restarted, your interest got compounded every year. So you started off with $5,000, you gained $500 in interest after the year. You would then, after that 1 year, you would then have $5,500, and your percentage of interest you're getting would be based off of now that $5,500. But we did that recalculation every year. So even though after 6 months, you may have earned $250 in interest, it's not going to be recalculated. You're not going to get your interest is not going to be based off of the $5,250. It's just going to be recalculated at the end of the year when the year's over. Then they'll say, okay, we'll recalculate it. Now you're going to get a percentage based off of what you now have in your account. Whereas compound continuously, what that means is the interest you're getting is continuously being compounded. So there's a good video you guys could watch if you're in my class. We're going to be watching it. It's about E and what E actually means, and it's really used for this right here to figure out if what we're investing is being compounded continuously. You'll eventually get to the number E. I'm too lazy. I'm not going to link it. But it's a good video. It's like, what does E mean? It's like a 2-minute video, if you guys want to find it. So I do all this to give you guys the formula of how we'd solve a problem like this. Did I read the problem yet? Drew deposits $3,000 into a savings account where he earns interest at an interest rate, that's weird, of 5% compounded continuously. How long will it take for Drew to have a total of $4,000? And we're going to use this formula right here. F equals I times E to the power of RT. Just like with the last video, if you look it up online, you're going to get a different formula. It's going to say A equals P times ERT. That's fine, it's the same thing. This is just the way it makes most sense to me because F, whatever this is, that's just talking about your final amount of money you're going to have. I is just talking about the initial amount you're investing. And then we have E as our base. That's just, remember, just the number E, like 2 point something. And we use it because that's how we want to represent being compounded continuously. R, this is just the rate, which will be represented as a percentage. And then T, that's just time. Okay. So now, just like I did for the last one, we're really doing the same thing for this problem as we did in the last one. So if the last video made sense, you're pretty much doing the same thing here. You're just plugging in, you're figuring out what these letters are, you're plugging them in, you're solving. So we have F, I, R, T. So I'm reading this scenario right here. I start with Drew deposits $3,000, just like in the last video. That's talking about the initial investment. So I is going to be 3,000. F, or no, my bad, not F. That's not how we do this here. We just keep on reading. 3,000 into a savings account where he earns an interest rate For year's interest, at an interest rate of 5% compounded continuously. So the rate is going to be 5%. So that's our R. We write it as a decimal as 0.05. How long will it take for Drew to have a total of $4,000? So it's saying how long will it take? So time, that's what we're looking for. And then the final amount being $4,000. So we're going to plug everything in. We've got 4,000 equals 3,000 times e to the power of, we said r is 0.05, and then we're looking for t. Okay, so with these last two videos, I did make things a little bit complicated for you guys, where I'm having you guys solve for the exponent. Just making it a little trickier. There may be different examples where I'm asking you to figure out what the final amount is, and that should be really easy. If I said it's going to take 5 years, how much money will we have? That'd just be super easy. You just plug in here, 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 plug this in your calculator, you're golden. But I'm making you guys work a little extra. So I'm making you solve for the exponent. So how we do this, the same steps as we did in the last video. We want to move this 3,000. How do we get rid of this 3,000? We got to divide both sides by 3,000. These cancel out. We're left with 4 over 3 equals e to the power of 0.05 t. Now, in the last video, we were left with a number equals a number to the power of a letter. And we decided there that we're going to use logs. But now we have the same thing, but this number is a very particular number. We have the number e. And so if you guys think back, whenever we have an e and we're trying to solve for its exponent, we use the natural log. So we actually use ln in this case, and we take the ln of both sides. So we have ln of 4 over 3 equals ln of e to the power of 0.05 t. And then since ln is just a log, it follows the same rules. It tells us we're allowed to move this exponent to the front of our natural log. And I'm going to move this up here now so I have more space. When we do this, we have ln of 4 over 3 equals 0.05 t times the ln of e. And if you guys remember, ln is just log base e, so this is really just log base e of e, which you guys should know that this just equals 1. This just equals 1, so we can cross it out, because when we multiply with anything, we're just going to be left with 0.05 t. So what we really have is ln of 4 over 3 equals 0.05 t. I'll write it out. ln of 4 over 3 equals 0.05 t. So now to solve for t, we just got to get rid of 0.05. So we can divide everything by 0.05. 0.05. These cancel out. We plug this into our calculator, and we get t equals ln of 4 divided by 3 divided by 0.05. And I get 5.75. So that really is 5.75 years. And so if you guys remember in the last video, I'm pretty sure we did the exact same thing. The only thing, like I said, that was changed was this word. We added the word continuously. And I think for the last one, it was 5.9. So just by that interest being compounded continuously versus yearly, we're saving time. We're getting that money faster. If we were to do a problem, which I'm not going to do, like I said in my last video, if my audience that's expanding rapidly would like to see more videos, such as how we'd find the final amount if we knew everything. If I compared those two, whereas compounded continuously versus yearly, you would see that if you invest that money for 5 years for both of them, you're going to be getting a good amount more from it being compounded continuously. And in this case, you're seeing that it's taking less time to get to that ideal number. So in life, if you can ever get continuous compound interest, please try to do it. Please try to fight for it. If you can get interest compounded as consistently as possible, if you can get compounded daily, that's amazing. Weekly, that's great. Monthly, that's fine. Even yearly, that's pretty good.